All right, I think we're on. Uh, Hello, everybody. I hope you had a long weekend, although every day seems like a weekend, right? But I hope the holiday weekend was good for you, and maybe you got to see some family or friends, whether it be virtually or in person at a good distance, and you enjoyed some of the festivities that you normally do, maybe in a different way. What you see here on the screen is a Meiosis flow chart, if you will. And what we're going to do is we're going to try to fill this in together and test your understanding here. I got a bunch of the slide presentations. I'm still working through them. I got some late last night, early this morning. So bear with me while I go through this. These aren't graded, that they're something to help you understand this. I got a couple of messages in the Google Classroom saying you didn't quite get this yet. When I looked at some of the slide presentations, I could see some of you didn't quite get it. So I thought we would go through this with this tool today and see if we can work our way through it. I'm going to do sort of like a question and answer. I'll just sort of pause and pretend we're in class. If you think you can answer the question, then go ahead and in your mind or out loud, if you feel like talking to your empty room or to your cat or your whatever, go ahead and answer it. So let's get started. This space right here is for interphase. It wasn't on here, so I am just going to try to mark this with an eye. This is where interphase is happening. It still happens. There's DNA duplicating, organelles duplicating, cytoplasm duplicating. Everything is growing and developing. This is where the cell will spend most of its time. After that, it's going into prophase. Okay, so let's start taking a look at what's going on here. What should we be drawing for prophase 1? Okay, hopefully you mentioned, maybe you said, some centrioles starting to form. And where are they forming? They're forming at the poles. That's correct. Something is coming out of them. This is like the fishing reel, and the fishing line is coming out. And think about where those are called as I draw them. These are called the spindle fibers. All right. All the organelles are here. All of it's still there. Cytoplasm is there, but we're not going to redraw it each time. Let me just make sure I'm still recording here. Yes, I am. That would be terrible if I went through all this and wasn't recording. All right, let's think about the nuclear membrane. How should we draw it? And if you're thinking or saying out loud with a broken line, then you are correct, because the nuclear membrane is breaking down. This is a lot like prophase like we did before, but there's a difference here. First of all, how should I draw these chromosomes? Since we're in prophase, everyone has a sister chromatid, so I should draw them with a full X. And we're also drawing them with their homologous pair. So I'm going to draw some here. Let me see. I think I can change the color. Now this color is representing, they're not different colors in real life, but what they are is similar. They're the similar size, they're a similar shape. So we're drawing a few chromosomes here with their homologous pair. That's supposed to be green. All right, and how many do we have here? Well, we started off with 46 of these. And then how many of these shapes do we have now? We have 92. We still say 46 chromosomes because we count them by these centromeres here. All right, so this is 46 of these, and there's 46 full X's. But there's 92 of these shapes because we doubled it. All right, and they're all here in their homologous pairs. Now we know some of them. Let's see if we can find a color that maybe you will see. Oh gosh, color selections. What should it be? What should it be? Brown. They will cross over. like that. And when they cross over, they're swapping genetic material. So we're getting some randomization here of genetic material. So that is prophase 1. All right, 92 chromatid. They're meeting up with their homologous pairs. They're oozing out into the cytoplasm. Centrioles form, spindle fibers form. Okay, metaphase. We're looking at this M here. M says what? Where are we looking at those chromosomes to be? And hopefully you're said to yourself, in the middle. They're going to line up in the middle with their homologous pair. So I'm going to try to line them up in the middle with their homologous pair, their dancing partner here. Metaphase 1, they're lined up in the middle with their homologous pair. All right. And our centrioles are still at the pole. And our spindle fibers are attaching. Now they're attaching to this one. This one is attaching to this one. This one's attaching here. This one is attaching here. And that's important because this one is going to go this way. This one is going to go that way. When we split this time, the homologous pairs are going to split up. So there's going to be a full X going that way. This one's going this way. That one's going that way. And that would be for all of the chromosomes across, right? So when we draw it here in anaphase, okay, we know A means they start to go away. A for away. All right. When I draw one here, I'm going to be drawing the brown one going this way, and his homologous pair going to the other side, the other pole. So that's coming back that way. Then our orange ones. This is probably fun to watch me click around. No, right? And this one's going this way. And we'll get our spindle fiber. That one's going that way. This one's going this way. Last one, mercifully, here. Green. This one's here. This one's here. All right, I'm going to give my hand a break from looking there. So what you're seeing here is we have 46 chromatid going this way and 46 chromatid going this way. So there would be 23 X's going this way, 23 X's going that way, each of them with 2. So that would be 46 going this way, 46 going that way. It still adds up to 92. We have 92 chromatid we need to account for. 46 of them going this way, 46 of them going that way. All right. All right. So telophase, what isn't in this diagram here is cytokinesis. Cytokinesis starts here in anaphase again. This cell membrane should be starting to pinch in, and we get that cleavage furrow. The diagram didn't have that, but cytokinesis is happening starting here. All right, so now we're in the telophase here. Let's see if I can adjust my mouse here to make this a little easier for all of us. Okay. All right, what should I be drawing here? Should I draw the centrioles and spindle fibers? No, I should not, right? I am going to draw, though, the nuclear membrane is back. Because we don't want things coming around. I'm going to draw my X. Brown X is trapped in there. Kinda. I overdrew it. My orange X is trapped in here. There it is. Kind of. And my green one is trapped in here. And the same thing goes down there. 46 chromatid in here, 46 in there. And the nucleolus appears again. A little dark region. Right there. All right, so this has 46 chromatid. And this one has 46. We started with 92 in one, and we've got 46 in each. Right? These are genetically different because we had some crossing over. Okay, so they're different from each other. Okay, prophase. Think about prophase here. All right, well, those nuclei start to break down again. Spindle fibers reform. Along with the centrioles. Let's see, we need some spindle fibers up here. All right, now, because the nuclear membrane is breaking down, our chromatid, our chromosomes, can start to ooze out into the cytoplasm. So we'll get our green guy out here. Green guy's out. Orange guy's out, playing around. Brown guy's out. And our homologous buddies are over here in a separate cell. Green guy's out. And we're doing this, we're only doing 3 of them, but there's actually 23 of them for 46 altogether. Need an orange guy. Okay. All right, metaphase II. Thinking of that M. Where should we draw these? They should be drawn in the middle. There's our orange guy. Green guy. Brown guy. Brown guy. Orange guy. Green guy. Okay. All right. So what should we draw else in here? Well, looking back at metaphase I, we should have centrioles and spindle fibers, right? One for you, one for you, one for you. Now this time, when they attach, okay, they're going to be attaching. You know what I just noticed? There's no anaphase here. No anaphase 2. Isn't that interesting? We're going to have to make up our own anaphase 2. Prophase, metaphase. I looked at this PDF I don't know how many times. I just realized there's no anaphase 2. Huh. All right. Well, that's great. Attaching to the centromere. Attaching attaching, attaching, attaching. I'm not going to say it again. All right. Now, we really have to start using our imagination here because there's no block, no circles for Anaphase II. What should happen here, though? What do you think is going to happen here in Anaphase II? Before Telophase II, there should be another set of circles here. I'd say Anaphase II. Right. This one is going to get pulled away here. This one's going to get pulled away here. So this orange one's going to split. And it's going to be half of it going this way, half of it going that way, half of it going this way. So if this has 46 in it, 46 chromatid, in Anaphase II, you're going to see half of the chromosomes going this way and half going that way. Let's see if I can find my... Ooh, that's wild. There I am. Lower lunch. I think I saved our Anaphase II here. Loading, loading, loading. Exciting. Can't believe there's no Anaphase II on there. Let's see. Cancel. Boom. Anaphase II. So those chromosomes that were in the center, there's our metaphase II, they're going to be pulled apart. The sister chromatid are going to be pulled apart. So 23 chromatid will be going this way, 23 will be going that way. 23 going that way, 23 going that way. Then, after Anaphase II, which isn't here, so annoying, we'd have Telophase II, where it splits and cytokinesis keeps happening. These keep pinching in. And if we had 23 going this way and 23 going this way and 23 going that way, each one of these would end up with 23, 23, look at that, perfect threes, 23, 23. Starting off with 92, they line up in the middle with their homologous pairs. 46 of them go that way, 46 of them go that way. They split into two different cells with 46 in each. Then they start to ooze out into the cytoplasm again. They line up in the middle. Anaphase II happens where half of them go this way and half of them go this way. Each of these split. So this splits into two. This 23 goes here, this 23 goes here. This 23 goes here, and that 23 goes there. So you end up with 4 cells that each have 23 chromosomes. Now, these are sort of useless on their own. So they have to get matched up with a 23 chromosome gamete from the opposite sex. So let's say this is... That's overdrawn. We'll get rid of that. So this is our salmon again. And this is the 23 from the dad and the 23 from the mom, salmon. They would combine together. You'd have one cell with 46. You'd have the full complement of genetic material. Well, this is really good except for the fact that there was no Anaphase II. Unbelievable. I don't know how long I looked at this and thought this would be perfect. Well, we tried. We did all right. So here's what I got. I have here, this was the meiosis test. And I'm going to put this in your Google Classroom, not as a test, not as a test. No grade, not graded. It's going to be a self-check. So if you were to take a test on this, if you were, which you're not taking a test on this, how would you do? How do you understand this? So think of these as self-check questions. At the end of a chapter, you'd have some review questions. Well, here's your review questions. As you can see, I've got 121 responses from the last couple of years. This was a hard test. This is not a test for you. It's a self-check. How did you do? The average was about a 65, which means they understood about half the material, a little more than half the material. They had some 600s. So I'm going to put this in your Google Classroom. It is not a test. I don't want an email asking if this was a test. Is this graded? Is this going in Skyward? This is not a test. This is a self-check. Okay? This is how well do you know meiosis? Right? Kind of like a review. Think of it that way. All right? So I'm going to put that in there. You'll see how you see. I'll see how much you understand. You'll see how much you understand, and then we'll see if we can move on from here. All right. It's just a self-check to see where you're at. Okay. Also, I am finished with the virtual field trip 2. Did not put it up last Friday because last Friday was not an official school day for you. So I'm finished with the virtual field trip, and I will put that up for this Friday, the center of Central Park. I put an email out about comic cards. If you sold comic cards, make sure you're checking that out. All right, everybody, this turned out to be a long video, but hopefully you're set up. If you want to do that self-check today, if you want to look over the meiosis stuff a little bit more before you do that self-check, feel free. I'll give you this week to finish up the meiosis, how you feel about it. Do that self-check. Not a test. Not graded. I know I'm going to get at least one email. I can't believe you gave them a test. Not. All right. It's supposed to be nice-ish today. Yesterday was not so nice. Just couldn't get outside. But looking forward to getting outside, getting some oxygen, and moving, getting out of my house, and still staying safe, and hopefully you are too. Okay, if anybody needs anything, reach out to me with a question, Google Classroom, or my email. All right, everybody. Bye.